Previously on Mr. Forth Programming. So now I'm going to try sine distance functions. I should be able to compare the sine distance function I write here to both the circle and the rectangle. I spent quite a bit of time there comparing two different rendering paths for the circles. The error was 20 out of 255, so almost 10%, a little less than 10%, but still quite a significant amount. And next time I will try to add in sampling along the vector of motion so that I can get the thin line case looking good like it did in the pixel coverage version, and see how that looks in the circle case too. And I think that will help with the circle case some amount. It might not, and we'll have to look at that and see what's going on there. And now, what I need to do today is combine the sine distance function with the motion blurring concept. But first, I need to correct a mistake. Previously, I tried introducing velocity clamping, but now I've realized that the way I did it is actually wrong. What I did was just independently clamp the x and y coordinates as if they're two separate variables. And the problem with that is that it can very often change the direction that a vector points. Now you might have the idea that the issue here is that I should be clamping it to a circular region, and that might actually be a smart thing to do, but I'm not doing that because clamping to a circle requires a square root, and I was trying to get away with not having to pay that extra price. In actuality, to preserve the angle of the vector, what I do have to do is to make sure that whenever I scale the vector down, I'm scaling the x and y coordinates by the same factor. It's a pretty easy fix, so I'm just going to get this done and retune my choice of my maximum velocity with this correct behavior, and then we'll move on to actually completing the sine distance function stuff. Alright, so I got a chance to play with the clamping and try out a couple of different ideas. The square clamping did get better when I fixed the bug, but I still saw some strange changes in the shape of the tail while I was watching it carefully. And so I decided I would try the circle clamping just to see how that looked. And on a first sort of glance at it, I did feel like it was slightly better looking. It just looked like the tail was not just exploding larger and smaller in unpredictable ways. It seemed like it was more locked to the speed of the moving rectangle. I'm still not totally happy with some of the things about how this looks, but I want to set it aside right now because the ideas I have for maybe improving the idea of the motion blur should probably wait. I'm still trying to combine motion blur with the sine distance function stuff. So I'm going to set aside the issues with the fast moving blur tail and what I may or may not want to do there and focus instead on the slow moving part. And so what I've got so far is motion blurring with pixel coverage style anti-aliasing. And I want to combine today the sine distance function anti-aliasing with the motion blur and see how similar they look in the thin line case. That's the slow moving thin line, not the fast moving rectangle. And then I also want to compare them in the circle case. The shader part of that went super smoothly. I was able to just grab the two shaders, the velocity rectangle based shader and then the sine distance function shader, and sort of just smash them together. So the loop from the velocity anti-aliasing shader went in first, and then I pasted the sine distance function right inside the body of the loop to replace the pixel coverage stuff that was in the body of the loop from the original shader. And it all kind of just came together and started working. And I was even able to use the text dumper that dumps me out my exact values to confirm that it really was computing the exact same values when I looked at the sine distance function version of velocity rectangles as I was getting from the pixel coverage version with the velocity stuff. So that came out just right. While I was looking at that, some other stuff popped out at me that was a little surprising. I had thought that the way it was set up, I would never have 3 pixels. Like if I had something that was supposed to be 1 pixel wide, then I thought that as it was moving along, I would only ever see 2 pixels side by side. Even with a little boost in the width, I didn't think I would see 3 pixels all filled. But I guess it actually does fill 3 pixels when I boost it a little bit in its width. It's just one of them is so slight that I never visually perceived it. And then that took me down another rabbit hole because I was looking at it and I was sort of noticing the interim effect even with the boost, but there were some issues with how the boost was tuned. Some of it was stuff I thought I fixed before, but it's fixed again now. Maybe the fixes got lost when I was shuffling things around, or maybe my eyes just perceive things differently today. And if that's the case, then this is all getting a little fiddly, which I would like to avoid. But sometimes that's the nature of this. But the good news is I do have confirmation now that I got the sine distance function and the velocity-based anti-aliasing combined correctly. So the last thing I'd like to do today is play around with these features. Particularly, I've got rounded corners and outline thickness already implemented in the sine distance function that I originally wrote, so I want to get that integrated in here and actually see it working, which I haven't done yet. So I want to visually inspect the results of putting all of this together, and then we'll be done for today. All right, so I was able to get the outline stuff up and running and test it out for a bit. I think I'm ultimately going to make the decision that putting boost in at the layer where I was putting it before, remember boost is the thing where I modify the velocity that I pass down so that when it's close to 0, it gets a little bit bigger. And I think that I've decided not to actually put that in at that lowest layer, so that what should actually happen, I think, is that the velocity gets applied exactly as the user asks for it. Obviously, I'm still going to have clamping lower in there so that the lower layer guarantees that the performance problems won't show up. And that is just something that the user can't get access to, sort of the velocities above a certain level. But I want them to be able to put in whatever velocity they want so that they can tune for themselves what kind of boost characteristics they need. Because as I was playing with it with a square that's an outline that's moving around, it turns out that the boost rule that was working for just a single line wasn't really working for that square, and the sort of things you would do with that particular example I had weren't going to be the same as what you would do in other cases. How you would tune the boost would be depending on what you were doing. Another way to put it is there's no way to make this work by ignoring the fact that the effect really emerges across multiple frames. It's not possible to think of this as a bunch of still images and have them all calculated directly from knowledge of the velocity. In order to actually do the right thing, you also have to know what happened on the previous frame and what you're planning to do on the next frame a little bit with the animation. If you don't know that, then you don't have enough information to automatically do the right thing. So I've taken the boost concept out of the lowest level and moved that up to where the user can use it. So the velocity parameter is just a new ability of the renderer, but it's not necessarily going to make your lines look smooth like I was originally trying to do it. You have to use it appropriately, boosting it when you need to boost it, putting in thresholds and clamps when you need to on your own. And of course, like I said, I'm still going to put a clamp in at the lowest level just because we need that for performance. On top of that, I also finished combining all of the things with rounding and thickness and adjusting the geometry and all of that into one big path. So I have one code path now that combines all of the shape relevant features. And so all we have left to do now is start looking at color relevant features. So that's what we'll get to next time. See you then.